Okay, sometimes the law of sines is not applicable, right? So we have to use another, right? There's another way that we can solve a triangle if it has a certain other types of information. So remember, with a triangle, in order to use the law of sines, we have to know one side and the angle across from it. Okay, if we don't have that relationship between the side length and the angle across, then we can't use our proportions in order to solve any triangles. Okay, so there's another way. So this would be if we had a side angle side situation, meaning we know two sides of our triangle and the angle in between them. Okay, if we know that situation, we're going to use the law of sines. The law of cosines. And if you'll notice, the law of cosines has what trig in its equation? It has the cosine of our angle. Okay? Now all of these are basically the exact same formula with a couple of different nuances, so you need to pay attention. If we're solving for side C, that means we are finding the cosine of angle C. Right? We have to know this angle C in order to find side C. We also need to know the other two sides, right? A and B, and C is the one in between there. Okay, so it doesn't matter which angle or which side you are trying to find. If you're trying to find side B, then we need to know angle B. Okay, so we can only find the side across from the angle that we know, right? So that's one of the stipulations of the law of cosines. So if this is our first problem, right, look at what we have. We have, here is little a, right? This is little side A because it's across from angle A, and the angles are always across from their sides. That means 3 is little side B because it's across from its opposite side there, or opposite angle. So we can use the law of cosines to calculate side C. Right? We cannot set up a law of sines because we don't know this proportion between the opposite side and an angle. Right? We don't know any of those for any of this information about our triangles. So thank goodness we have the law of cosines. So this is going to be our angle C that we're going to use in our formula. Okay, so this is how it works. We're trying to find side C, so we write C squared equals. Okay, it's a Pythagorean type of a problem because all of your sides are squared. C squared equals 2 squared plus the other side squared, and then minus. So it's always B squared and A squared plus together, and then minus 2 times the A side times the B side times the cosine of the angle in between them. So cosine of 60. Okay? So the 2 is always there, right? 2 in the middle, the 2 in black color, is always a part of your equation. Okay? Don't forget about this 2. No matter what else is going on, these all have a multiplier of 2 that's being subtracted. So now this is just a matter of putting it into our calculator. So whatever calculator we have, I have an Inspire, so I can put this all in at one time. 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 60. So hopefully your calculator is in degree mode, right? Because we're taking the trig of a degree angle. And this comes out to be exactly 7. Okay, but now there's one more step because it's C squared. I have to take the square root of both sides, and C is the square root of 7, which is approximately 2.6458 would be the value of C. So now that we know one of the sides and the angle across from it, right, we can use the law of sines to find everything else. So we know this ratio. We know this is 2, well, let's just go back. This is the square root of 7, right? Anytime we can use an exact value and not a decimal approximation, use the exact value. So C is the square root of 7 over the sine of 60. And then let's just find A first. So 2 over the sine of angle A. So let's do this, right? The law of sines is a pretty good thing to use when we're trying to find another angle from a triangle. You could also use the law of cosines, which we'll talk about here in a minute, how you use the law of cosines to find an angle. Okay, so let's cross multiply, because finding an angle is the hardest thing to do with the law of sines. So root 7 times the sine of A equals 2 times the sine of 60. Divide both sides by root 7. Okay, means the sine of angle A equals 2 sines of 60 divided by root 7. And then we move the sine over by taking the inverse. So this is what we're going to put into our calculator to figure out what the measure of angle A is. Okay, all at one time without any decimal approximations. The inverse sine of 2 sines of 60 divided by the square root of 7 is, rounding to one decimal, 40.9 degrees. Okay, so first we use the law of cosines to figure out what that opposite side was. And once we have the opposite side, now we can use the ratio for the law of sines. And of course, our third angle is always found by using geometry. So angle B is going to be 180 minus 60, which is angle C, minus 40.9, which is angle A. And my answer comes out to be 79.1 degrees. So we will always be finding 3 things about your triangle. In this case, we found a missing side, and then we found 2 missing angles. So let's look at our second problem. We can use the law of cosines to solve a side, side, side. So notice that we don't know any angle measures here. And in order to use the law of sines, we have to know at least one. So as a general rule, whenever we're trying to solve a triangle using law of cosines, we want to find the largest angle first. Okay, find the largest angle first. And the largest angle is always across from the largest side. So in this triangle, my largest side is called 6, and 6 is across from angle C. Okay, so we're going to use the law of cosines as it's written, and we're going to solve this for angle C. Okay, so this is going to be a little bit of algebraic manipulation to begin with. So the theorems, the law says we do 6 squared equals 4 squared plus 3 squared, right? Those are your A's and your B's, where C is the side across from the angle we're trying to solve. Okay, 6 here is the side length across from the angle that we're trying to calculate. That's a really important concept to get into your brain. Okay, minus 2 times 4 times 3 times the cosine of angle C. Okay, angle C is what we're going to calculate. It's across from the largest side. Cosine of angle C. So there's a couple things that we could do. Let's just do it simple, right? We know 6 squared is 36. We know that. Hopefully we know that. 4 squared is 16. 16 and 9 is 25, minus 2 times 4 times 3 is 24 cosine of c. Okay, so this is just doing our algebraic simplification. Now we're going to subtract 25 from both sides, right? Bring the 25 over to here. 36 minus 25, I believe, is 11. So 11 equals negative 24 cosine of angle C. And now divide by negative 24. So this leaves us in a little precarious, no, it's not precarious at all, it's fine. Negative 11 over 24 is equal to the cosine of angle C. So once again, if we want to find an angle, we have to move the cosine to the other side by taking its inverse. Anytime we find an angle, we're going to be using the inverse trig function. So the inverse cosine of negative 11 over 24. Okay? So this is going to tell us, by the way, that we have an obtuse angle. Okay? Just by the fact that cosine is negative. Cosine is negative in the second quadrant of our unit circle, correct? So our angle is going to be somewhere over here, greater than 90 degrees. Okay? The law of sines would never tell you that. The law of sines is only a first quadrant angle to begin with. So that's another good thing about the law of cosines, is it can give you an angle greater than 90 degrees. So the inverse cosine of negative 11/24 is 117.28, which we're just going to round to 117.3. 117.3. Okay, so that's the measure of angle C. Does it look like 117? Sure, but not all triangles look the same, right? And if you're not given a triangle picture, then you're going to have to decipher this kind of on your own. So let's do some derivation real quick, okay? Because I want to use the law of cosines to solve for another one, right? We could use the law of sines just fine, because we know now this is 117.3 degrees, so we could use the law of sines to find everything else. But let's just practice using the law of cosines. So what if I wanted to find angle A? What if I wanted to find angle A? Well, if we work backwards with what we did over here, we know that the measure of angle A is the inverse cosine of some stuff. Right? So let's see, what is the inverse cosine, some stuff. So here we have, right, that's the side across from it. So the side across from angle A is little a, and that's a positive. And then we subtracted the sum of our other two sides. So in other words, we need to subtract b squared and we need to subtract c squared from the a squared. Okay, and what else did we do algebraically? We divided by negative 24, which was all this stuff. This is 2 times your other two sides. Divide by negative 2, in this case, b and c, right? Because b and c would be our other two sides. So this would be a derivation of a formula that we could use in order to find the measure of the angle pretty much straight away. Okay, so I'm going to do one other thing here, and that's get rid of all of these negatives. Okay, I'm going to change the signs of all of my negatives. So it's actually b squared plus c squared minus a squared divided by positive 2bc. Okay, so a little bit of a change. Now we have the side that we're trying to calculate, right, across from the angle is now being subtracted. Okay, because these are all negatives, so if you change the sign of the numerators and the denominators, these become pluses and the a becomes a minus. Okay, this is a pretty powerful formula that you don't have to memorize. You can always use algebra to calculate it just with your given information. So let's see, what is our given information? We want to find the measure of angle A. So my B side was 3 squared plus, C was 6, and A was 4, so minus 4 squared. All over 2 times 3 times 6. So this is going to allow me to put this all into my calculator all at once. Inverse cosine of, I have an inspire, so I hit Control Divide to make a fraction. 3 squared plus 6 squared minus 4 squared divided by 2 times 3 times 6. And when I do that, I get a measure of angle A of 36.336. Let's just go with 36.3 degrees. Okay, just to practice using our law of cosines to find an angle. But always and forever, anytime we have two angles, we find the third angle, in this case angle B, by doing 180 minus the other two angles. There's no easier way to find an angle than to use geometry and just subtract. (26.4 degrees). Okay, so this always works. We always want to find the biggest angle of our triangle first. Okay, that way we are eliminating the ambiguous case of the law of sines. If you find the biggest angle first. And remember, the biggest angle is always across from the biggest side. So whenever we have a side triangle, and we're trying to find the angles of your triangle, identify the largest side and use the law of cosines to find the angle across from that. That is all for the law of cosines. Hopefully this helps. Have a great time.